Problem number 6 and 7 require the use of the graphing calculator. With problem number 6, we're told that f is given a derivative of cosine squared of x over x minus a fifth. And we're asked how many critical values does f have on this open interval from 0 to 10. A critical value occurs when the function has a derivative which is equal to 0. So we need to find when this derivative is equal to 0. So let's bring in the calculator. Okay, and we've placed cosine of x squared over x minus 1/5 into our y1. Now we're interested on the domain of 0 to 10. So we're going to hit the window button, 0 and 10 as our x-min and max. And we're interested in when the function touches the x-axis. So we got to really close in. So let's make this like negative 1.1 and 1.1. So or just negative 1 and 1. That's fine. All right. So we're really looking close to the x-axis from 0 to 10. So now when we graph this function, we're looking to see how many times does the graph touch the x-axis. Alright, and we can see, now if this is a little too hard to see, we can always zoom in more. We can see clearly 1, 2, 3 times in which this graph touches the x-axis, and therefore 3 critical points. Now, again, if you can't see if that's close or not, we can always go back to the window, and we can always make this something more like negative 0.5 and 0.5, or even negative 0.1 and 0.1. And we do that, if we're zooming in more on that x-axis, we get more of a differentiation between the axis and the curve. We can see that there's definitely some space there. So 3 times between 0 and 10, the curve of the derivative touches the x-axis. So our answer is 3. With problem number 7, we're told the derivative of a function is x squared cosine of x squared. How many inflection points will f have on the interval from negative 2 to 2? Now, an inflection point is where the second derivative crosses the x-axis. So one way we can go about this is to derive this f prime, get the second derivative, and figure out when this second derivative would cross the x-axis. But we also know that a point of inflection occurs when the first derivative has a relative extreme, when the first derivative changes from increasing to decreasing or vice versa, when there's a relative max or relative min on the graph of the first derivative. So maybe we can try that first so we don't have to worry about any derivatives. So I've placed x squared cosine x squared into y1, and we're interested on the domain from negative 2 to 2. So we're going to hit our window button, type in negative 2 to 2, and I'm going to go back to a y min, let's make it negative 5, and a y max of 5. Now we can look at our graph, and we can see this function right here. All right, and we know, again, that this is the graph of the first derivative right here, and a first derivative, when it has a relative extreme, the function has an inflection point. So we've got a relative min here, a max there, a min at the origin, another max at 1, and then finally another min. So there's 1, 2, 3, 4, 5 total relative extreme values on this derivative graph. So we are looking for 5 as our answer. Number 8 is not graphing calculator active. Instead, we see the graph of f is shown above. This is the graph of the original function. Which of the following could be the graph of the derivative? So our function is negative, positive, and negative, but that doesn't really help us in regards to the derivative. More importantly, our function is increasing, and then just after the y-axis, our function begins decreasing. Increasing and then decreasing behavior means a derivative which is positive and then negative. So let's take a look. For 8a, positive and then negative. For b, always positive. For c, negative and then positive. And d, positive, then negative, but then positive again. Again, we have a graph which is only, between a and b, only increasing and then decreasing. So we want a derivative which is positive and negative only. So we're going to pick option A.